Hello, my name is Maverick Collins. This is my video submission for Milestone 4, Embedded Release 3 for Embedded Systems 1, Software Engineering 350 with Professor Woodward here at Grand Canyon University. And in this assignment, we were tasked to have working FPGA functionality. And I kind of ran into um, a big problem with my putty. My LCD panel died, so I'm using an external monitor. You guys can see. Ah, okay. Anyway, I'm using an external monitor, and my laptop died on me, and I tried to update the drivers during Thanksgiving, and I think I may have deleted the driver for the DE10 board, and as a result, I can only console in, serial in via PuTTY. I can't SSH in. And to get the LCD panel to output on the board, I can't even say how many files and libraries that would be, instant with FileZilla, but I don't really have that option. And we're kind of against the deadline today. I present today, and yeah, I fly out tomorrow for a surgery. So I figured I just submit this and show Professor what I had overseeing this, the World Wide Web. So anyway, this is my Pac-Man FPGA game. Um, this has been a semester-long project, and as you can see, I have all my directories open. We got our includes, our lib, which has our address map, our source code, which is segmented into game logic, and then the main, I guess I should say modulated, and we also have a utility library. Um, so I was able to design a working Pac-Man game within the console. The first or last release, I had it with just the Pac-Man and the pellets and the maze, and it outputs at a frame rate of, I think it's right here in the game. The main C. Okay, it's in the main C. Yeah. So basically, there's a while loop that's running this thing that's outputting the whole render, and I did the math. It's 1 over 120 milliseconds, which is roughly 8 frames per second, which you're about to see in a second here. So 8 frames every second on the console. It appears like it's a movie, right? That's exactly how a movie works. It's just a repeated image over and over and over again. So pretty sweet. Disappointed I couldn't get it outputted onto the FPGA here. Yeah. Anyway, so without further ado, let's go ahead and give this thing a run. Okay, so I'm in my folder directory and I have to be pretty fast. I've already compiled everything. And when I run it, I'm gonna use my up, down, left, or right arrow keys for the cardinality to move Pac-Man. So it'll go really fast. Bear with me. Oh, okay, he died. So let's try it again. Oh, you have to go really fast. Oh, I ran into the ghost that time. So the ghost is a little lightning bolt. Ah, it's really difficult. And it's not, all right, that's probably my best run so far. Um, so output's the still maze. As you can see, where is it? Right here. Hard coded in. And the ghost logic, I think, is the other most notable thing, which it uses basically it uses what's called the Manhattan algorithm, where it looks in all directions and it looks for the shortest path to Pac-Man. So this is exactly what's used in normal Pac-Man. And so we're pretty much porting it over to this instance, and not reinventing the wheel. Other than that, there's a lot of modularity to this code. We could update the maze. We could update the refresh rate of the game here. Um, the score hasn't been implemented yet, along with the um, when he goes through one side of the maze, it's supposed to pop out the other end. I hope to implement that next semester for me to continue this project, along with finish the FPGA, assuming we're still using the DE10 standard board. Um, but yeah, that's all I have. That's going to conclude it for my video submission for Milestone 4 Embedded Release 3. I hope you enjoyed it. Professor Woodward did a great job teaching this class. He was given this course kind of on short notice this summer when one of our legacy professors left the university. And I think, you know, he did a great job with the tools he had at hand. And I learned a lot about the FPGA this semester and became a lot more comfortable with serial and SSHing in and getting the interface with these FPGAs is a really great opportunity as software engineers. So thank you, Professor Woodward. Tip my hat off to you and look forward to next semester with your class and whether we're using this board or a different board, it'll be great. I hope we can continue with this though, because I would like to continue to improve upon this once I have my new laptop. So as you can see, that moving the monitor made that move. Yeah, like I'm touching it. Anyway, all right, that's all. Maverick Collins, and thank you guys for your attention. We'll see you guys on the next one.